All right, guys, welcome to 10.4 compound events. This is our second section of week 2 of distance learning. So we talked about experimental and theoretical probability. We're going to go a little bit back to theoretical probability, maybe do a little bit experimental too, but now we're doing compound events. So we know what an event is, right? If the experiment is rolling the die, the event is rolling a 3 or rolling evens or rolling odds or rolling not a 4 or less than 3, right? The event is specific, but compound events just means multiple events. So now we are going to be doing more than one event. So first we need to understand what a sample space is. So a sample space is all the possible outcomes. And we're going to be using tree diagrams to find the sample space. So just remember that sample space is all the possible outcomes. It's like a giant space, and we're just putting our answers into there. So let's count all the possible choices of this example. A school team sells caps in 2 colors. You can get the hat in blue and white. You can get it as a child or an adult size, or you can have 2 fabrics, cotton and polyester. We need to draw a tree diagram to find the number of cap choices. So suppose you walk up and you say, okay, what color you want, right? You would pick a color. So you would either pick blue or white. That is 2 options, right? Suppose you pick a blue hat. The next question will be, would you like a child or an adult size? So you can put child and adult. But what if you would have chosen a white cap, a white hat? You could have gotten a child size or you could have gotten an adult size. So right now you have 4 options you could have gotten. You could have got a blue cap in a child size, a blue cap in an adult size, a white cap in a child size, and a white cap in an adult size. However, you're not done yet. There's different materials or fabrics you could have gotten. You could have gotten cotton or polyester. So therefore, if you would have gotten a blue cap in a child size, you could have gotten it in cotton and polyester. But what if you would have chosen the blue cap in the adult size, or the white cap in the child size, or the white cap in the adult size? All those options, you could have gotten cotton or polyester. This means that we went from 4 choices to 8 choices. It doubled. Our first option we could have gotten is a blue cap, child size, and cotton. But we also could have gotten a blue cap in a child size in polyester. Just follow the lines. After blue cap in a child size in polyester, you could have gotten a blue cap in an adult size in cotton, or a blue cap in adult size in polyester. Those are all 4 options for a blue cap. But you could have gotten the exact same 4 options just with a white cap. Notice white cap, child size cotton, white cap, child size polyester, white cap, adult size cotton, white cap, adult size polyester, white cap. Oh, sorry, that's all of them. 2 choices, 2 choices, 2 choices, right? You had 2 choices for color, 2 choices for the size, 2 choices for the fabric. That comes out to 8 choices. So how do you get from 2, 2, 2 to 8? Multiply. You multiply the events. 2 choices times 2 choices times 2 choices give you 8 outcomes. I'll let you guys settle in on that for a second, and then we're going to go to the next slide. Remember, you can pause it. Now we're going to apply the fundamental counting principle. This is also what we use, the multiply. You have 4 shirts, 6 pairs of pants, and 8 pairs of socks. How many different outfits can you wear? This is an important slide, guys. The fundamental counting principle is when you multiply each number of choices to find the total number of outcomes. You multiply all the choices together to find all the number of outcomes. I'm gonna go back to the last slide. You had 2 choices for color, 2 choices for size, 2 choices for fabric. 2 times 2 is 4 times 2 is 8. So here, if we're gonna multiply the choices to find the total number of outcomes, we have 4 shirts, 6 pants, and 8 socks. So what we need to do, 4 times 6 times 8. That's going to give us 192 outfits. That means if you only had 4 shirts, 6 pairs of pants, and 8 pairs of socks, you can get through every single day of the school year without repeating an outfit. Granted, you will have 8 days where you wear the same shirt and the same pair of pants, but just have different socks on, so people might not notice. But you could get through the whole school year wearing a different outfit with just 4 shirts, 6 pants, and 8 pairs of socks, because 4 times 6 is 24, 24 times 8 is 192. That is the fundamental counting principle. The fundamental counting principle does not tell you all the outcomes. It just tells you the number of outcomes. All right, so like I said, compound. What is compound? Compound means multiple, 2 or more events. So if we want to understand compound events, you first need to know what compound means. Compound is multiple. So now we are working with more than one event. We need at least 2 events to occur in order to find the correct probability. So for example, we want to find the sample space for rolling a number cube, so rolling a die and flipping a coin. Let's look at all the possibilities of rolling a die and flipping a coin. Well, if you roll a die, you can get 1, 2, 3, 4, 5, 6. If you flip a coin, you can get heads or tails. So that means all the possibilities are: you roll a 1, you flip heads. You roll a 1, you flip tails. You roll 2, flip heads. You roll 2, flip tails. You roll 3, flip heads. You roll 3, flip tails, and so on, all the way to 6, flip heads, 6, flip tails, right? So the probability of rolling an odd number, this is our first example, probability of rolling an odd number and tails. We need both of them to occur. So I want you guys to look in that option. There's 12 of them because rolling a die has 6 numbers, right? So 6 numbers times flipping a coin with just 2. 6 times 2 is 12. 2 for 1, 2 for 2, 2 for 3, all the way up to 12, right? So odd number and tails. Well, look, rolling a 1, flipping tails. Rolling a 3, flipping tails. Rolling a 5, flipping tails. That's 3 options right there, right? But how many options are there total? There are 12. So if we want the favorable over the possible, there are 3 favorable, 3 correct ones, but there are 12 total, which simplifies to 1/4. So the probability of an odd number and tails is 1/4. Let me show you guys another way to do this. One more way to do this is to find the probability separate. You can find the probability of odd multiplied by the probability of tails. What's the probability of rolling an odd number? Well, if you roll a die, there's 6 choices, right? But 3 of them are odd. So I'm going to cancel that out because that can simplify to 1/2. So you have a 1/2 chance. What's the probability of flipping tails? Well, you have heads and tails. You have 2 options, but only one of them is tails. Well, 1/2 times 1/2 is 1/4. And notice you have the same answer. All right, let's go ahead and go on to the next example. We want to find the probability of the compound event using a tree diagram to find the sample space for tossing a nickel, a dime, and a quarter. So first, if we're using a tree diagram, we need the nickel, the dime, and the quarter set up. So first, toss a nickel. What can you get? You can get heads or tails, right? But then, if you flip heads the first time for the nickel, now toss the dime, you can get heads or tails, right? But you can also get heads or tails if you flip tails for the nickel. So you could land on heads and then heads, or heads and then tails, or tails and then heads, or tails and then tails. But we still need to flip the quarter. So if you flip heads for the nickel, heads for the dime, you can flip heads or tails for the quarter. Or you could flip heads or tails for all 4 options. So how many total sample space is there? There's 8. You could flip heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. I know that's hard to see, but follow the line. Start with the H on the left and then move over to the next H or to the next T, and then move over to get your answers. Okay, let's find the probability of only one tails. So only one tails, look at the sample space. Which one has only one tails? Well, that first one has only one tails. There's another one with only one tails right underneath, and then there's one more with only one tails. So that means if we want the favorable, which ones have only one tails over the total number, 3/8 is the probability of only one tail. Now let's find the probability of at least two tails. So two tails or three tails. We have 1, 2, 3. This last one is three tails, so it counts. So that's 4/8, which simplifies to 1/2. So you have a 50% chance of getting at least two tails. Kind of interesting. All right. I believe that is the last slide. Yep. Homework is due Friday, May 1st by midnight. It's Big Ideas 10.4. Just go on Big Ideas website and work on it. Sweet. If you don't want to do that, you can go ahead and do it out of the book, number 6 through 20, 31 through 33. So that's 15, 18 questions. I know it's a bit of a lot, but guys, it's pretty easy. You find the probability of the two, and then multiply them together. Or if you want to do fundamental counting principle for some of the problems, which you'll need to, you just find the total number out. I know you guys can do this. So challengers, have a great rest of your day. Good job with this, and I will talk to you guys later. So challengers, see you at office hours.